In section 1.3, we will solve and graph linear inequalities. The goals of this lesson include solving linear inequalities in one variable and then also graphing linear inequalities in one variable. So when we talk about solving linear inequalities in one variable, you want to remember that an inequality is a non-equal comparison between two numbers or a mathematical expression. So we remember that these are the greater than, less than, greater than or equal to, or less than or equal to symbols. Our steps are going to be to solve the inequality using the same process you use to solve the linear equations. One thing we want to remember though is when we're dividing by a negative, we need to flip the direction of the inequality. So when we go to graph an inequality, we'll start by placing a circle on the critical value. From there, if you get the greater than symbol or the less than symbol, we're going to use an open circle. So we're filling that in on your note sheet. If it's greater than or equal to or less than or equal to, this is when we use a closed circle. Step 2 then is going to be to shade the side of the inequality that makes the statement true. In this first example, we want to start by looking at the type of inequality we have here. So this is the less than symbol. And because it's just the less than, it doesn't have an equal to, it's going to be an open circle. So eventually we'll be putting an open circle on this. Since there's no numbers provided here, you can go ahead and put it anywhere you want. Once we get the critical value by solving for k here, we'll put that critical value down here and we'll graph accordingly. So from here we will divide both sides by -7, just like we would do if we were solving an equation. We end up getting that k is greater than -9. And hopefully you notice that I am flipping this inequality here. As soon as I divide by a negative number, so as long as the denominator here is negative, we have to flip the direction of the inequality. Now from here, now I know that my critical value is -9. So I can put the -9 here by this open circle, and now we have to talk about which direction it's going to be shaded. This is saying that k has to be greater than or bigger than -9. So the numbers that are going to be greater than that would be on this side. It'd be -8, -7, -6, and continue on. So our arrow is going to go that way. For number 2, as soon as we look at this greater than or equal to symbol, we automatically know it's a closed circle. So again, I'm going to put a closed circle on my number line. I couldn't do that if I had numbers written here, but since there's no numbers written here, I'm going to put it right in the middle, and then once we find that value, we're going to put it right here underneath that. So from here, if I start by subtracting 57 on each side, I end up getting -4t is greater than or equal to -44. From here, to solve for t, we have to divide both sides by -4, what we're trying to get rid of. We are dividing by a negative here, so we do need to remember to flip the direction of the inequality, giving us t is less than or equal to 11. So again, we did divide by a negative, so we changed the direction of the inequality. We can put that 11 down here underneath our circle now. And now we need to talk about which direction the arrow is going to go. This says t has got to be less than or equal to, which means that it would be smaller than. So that's going to end up shading our left side here. Now there is a trick to this that can help us to remember which side is shaded. It only works if our variable is on the left side, which both of these are. As long as your variable is on the left side, all you really need to do is think about the direction that that arrow points. This arrow is pointing towards the right. So we want to graph this as it points towards the right. This arrow is pointing towards the left, so we can make this one point towards the left. So we're going to try these next examples. For number 3, we'll start by looking at the less than symbol. That tells us it's an open circle, and I can plot that. From there, we'll go ahead and distribute the 2. We can combine like terms here, giving us 2m plus 1 is less than 21. And continue solving, subtracting 1 on each side, getting 2m is less than 20, dividing both sides by 2 here. Now we're not dividing by a negative, so we do not flip the direction of the inequality. We end up getting that m is less than 10, so now we can fill in that critical value down here underneath the circle. And again, if you follow my trick that I talked about in the previous examples, since this variable is on the left side and the arrow is pointing that way, our arrow is going to point that way as well. It's a good idea to check to see that this is accurate by finding a value that would be in this region, and an easy one to pick because it would be part of this region would be 0. And if you plug the 0 in for your m value up here, you just want to make sure that it's a true statement. So I'll talk about that real quick. 0 minus 3 would be -3. 2 times -3 is -6. -6 plus 7 would give us 1 on this side, and is 1 less than 21? Yes, it's a true statement, which means that we did shade the correct region. For number 4, we want to start by noticing that we have a greater than, which means it's an open circle that will plot on our number line. From there, we can distribute the 9 on both sides, giving us 9x plus 18 is greater than 9x minus 27. Again, we want to get our variables to the same side. So we're subtracting 9x on each side, which again is going to be a special case. We have no more variables left. So here I'm getting 18 is greater than -27. Now you're going to use the same process we did before to determine if it's going to be everything that works or nothing that works. If this is a true statement, then every value for x will make this a true statement. So since this is true, we are going to have infinitely many solutions. And the way that we would graph this is that we really don't need that critical value anymore. We're just going to go ahead and graph all the way across the number line. If it was no solution, you wouldn't be able to graph anything at all. In example 5, we'll notice that this is less than or equal to, which tells us it's a closed circle. We'll go ahead and plot that. From there, we can distribute the -6 in, giving us -12x plus 60 plus 12x is less than or equal to 180. We can combine like terms on the left side there. So we get 60 is less than or equal to 180. Once again, we lost our variables. That tells us it's a special case. Either all real solutions or infinitely many solutions, or we could say no solution. From here, this is a true statement. 60 is less than or equal to 180. So we're going to get infinitely many solutions, which means that for the graph, we don't need that circle. And when we graph it, we graph the whole entire thing. And then for number 6, we have a greater than symbol. That means we're going to have an open circle, which we'll plot. From there, we subtract 14 on each side. We get -4y is greater than -1. Here again, we're trying to get rid of the -4 here, which is what we're going to divide by. As soon as we divide by a negative here, we have to flip the direction of the inequality. We should be getting y is less than. Now, I know, again, when we see the 1 and 4 together, it's really important that we pay attention to which is in the top and which is in the bottom. First of all, a negative divided by a negative is going to result in a positive solution, and then 1/4 does not reduce, so we leave that as 1/4. Down here, when we go to graph this, again, because our variable is on the left side, we can pay attention to the fact that that points to the left, and we can sketch it appropriately. Okay, for today's homework, what we're going to look at is in Delta Math. We have 3 different sections, all under the Algebra tab. They're preloaded into the system for you, and if you have any questions, please let me know.